Welcome to Physics Horrors. Today we're going to talk about bad physics which can be seen in TV shows or movies. Let's start off with projectile motion. The video clip that you will see momentarily shows a major physics mistake in projectile motion in the movie Speed. Can this really happen? Well, a projectile is an object that is kicked, batted, or otherwise launched into motion and then allowed to follow a path determined solely by the influence of gravity. Gravity has a tendency to bring things down. A projectile has a parabolic shape due to gravity. When something is launched, it must come down and it comes down in a parabolic motion. As seen in this video, the bus was supposedly going fast enough that it was able to overcome its downward vertical velocity and it jumped a 50-foot gap from a flat surface to another flat surface without any sort of incline or lower surface. This is impossible. It is incorrect because gravity would have made the bus go down. Therefore, in order for the bus to have made it across, it must have had an incline and much greater velocity, or it must have jumped to a lower surface. We must keep in mind that vertical and horizontal motions are independent of each other, so no matter how fast the bus is going, should it launch horizontally, it would always decrease enough to not make it. To prove that this cannot happen, we will use the range formula showing us the angle that we would need for this to happen. The range formula is shown below. Range is equal to initial velocity squared over acceleration due to gravity times sine times 2 times the launch angle. We would then put in our givens, which are 50 feet, 67 miles per hour, 9.81 meters per second squared. At the bottom of the sheet of this paper, the conversion just showed on how we turned all of these things into the meters per second. We would then rearrange the formula to solve for the launch angle. We would end up with theta is equal to half sine inverse times gravity times range over initial velocity squared. The ending result is 5 degrees. So in order for this to happen, the degree would have to be 5 degrees. Now we move on to Newton's third law. In the video clip in which we're about to see, we will observe a major physics error committed in Newton's third law. Newton's third law states that for every action force acting on an object, there is a reaction force acting on a different object. It also states that the action and reaction forces are equal in magnitude and opposite in direction. Assuming that both women weigh the same mass, 54 kilograms, it makes no sense that with the force that one exerted on the other, one flew, which by the way is defying gravity and is unrealistic, and the other one stayed and didn't do anything. The one who exerted the force should have at least flown backwards with the same force or gotten hurt of some kind. Do an example. For instance, let's use the formula F equals ma, which is force is equal to mass times acceleration, to find the force that she exerted upon this person. Let's say that she was 54 kilograms. She had an acceleration of 2 meters per second. This results in 108 newtons. This cannot happen because she exerted too little force to make her go in such a great distance. We have come to our last chapter in our journey in bad physics in shows and movies. We will now present free fall and motion with constant acceleration. Keep calm and enjoy this video on the coyote. Freefall concepts. Freefall objects have a constant acceleration. Their velocity is increasing constantly. Due to little air resistance, they fall. Once thrown up, they fall right back down because there's nothing to keep them up there, and they're completely under the influence of gravity. So when the coyote runs off the cliff, number one, he's supposed to fall in a parabolic motion. Number two, when he stops, he's suspended in the air. He's not supposed to be suspended. He's supposed to fall because he's completely under the influence of gravity. And there's no air resistance. Now, with motion and constant acceleration, the problem is the time that it took the coyote to fall. The TV makes it look as if it took the coyote forever to fall, when in reality, with these calculations shown below, it only took a few seconds. Thanks for watching!